Hello, this is my English speaking practice. From today, I'm gonna work on the problems, hard problems. So the first hard problem is median of two solid arrays. Given two solid arrays num1 and num2 of size m and n respectively, return the median of the two solid arrays. The overall runtime complexity should be log m plus n. Okay. So example 1, 1, 3, and 2. The merged array is 1, 2, 3, so the median is 2. Example 2, num1 is 1, 2, num2 is 3, 4. The merged array is 1, 2, 3, 4, so the median is 2 plus 3 divided by 2, it's 2.5. And we should do it in O of log n, m plus n. M plus n, okay. Two solid arrays, okay. Two solid arrays, okay. M plus n, log n, m plus n. I see. So the naive solution, which is a linear algorithm, is checking the element from start and one by one for num1 and num2, and which one is the smaller one, and we pick one, and yeah, we are gonna build the merged sort, and yeah, we just pick the middle of the element of merged list. But that's not the answer, because it's not logarithm. So I think there is a log, so we should use the binary search or something like that. There is num1 and num2. A median over two solid arrays. Okay. Okay. There is m and n. If m if the merged sort, length of merged sort is even, so we have to pick two numbers. It's for right, for so the 2 and 1. Okay, and otherwise we have to pick middle. So we can find out the index of the middle of the merged list. So let me do some tests, some simulation. When we pick the one of the number from the numbers 1, and I want to find out where the number is located, is placed in nums2. Where is the number? So, for example, there are 3 elements, and nums1a, and there are 7 elements after that. And then we can find this value is this value has index a, so a plus 3 is the index. In merged list. Okay, and if it's is this something, for example, let me replace it, b and c. A plus b is the index in the merged list, and we already have a middle. It's a target value as the index, so if this is greater than middle, we have to We have to make it smaller. But my concern is when we change this value, the b would be changed, so a plus b is changes a lot, but but it's not wrong because they are solid and solid. I think this might work. Okay. There is a case where this doesn't work because a plus b indicates the number of the number in the nums1, but the medium might be in nums2, so a plus b does not always equal to middle. Yeah. And also when we try to find out where is the number placed in nums2, this takes linear time, I think. So nums1 we have two candidates and I see. We have two candidates and we compare the a plus b let me use x and y, and in this case okay. The smaller one is the merged list A plus B, and the bigger one is merged no, we cannot identify plus 1 because x2 might be smaller than y, so this is not true. Yeah, but anyway we can identify the is this correct? Merged A plus B. Not correct, because B minus 1, there is a B minus 1, and so the y0 is y0 is greater than x. This is not correct. Okay, I'm getting it. So but the basic strategy is compare two values and then move index. So this is not correct, and we have to care about this case. So there are some cases. For example, y0 is the y0 to y0 maybe we have 4 patterns when x is less than y, and how to find it. So, except for this pattern, we can identify the index, both of index, because this pattern, the x and x1 x2 is less than y0, so we might have y element between them, x2 and y0. Yeah, so we cannot identify the index in merged list because we don't know how many y elements until x2, right? But this case we know the y0's index and we know the x2 index, and it's y0 is y0 is between them, so so until y0, the x is the index is a, so there is a and this is a plus 1. Okay, and y0 is b minus 1. So at this point, a plus 1 plus b minus 1. So we can identify the index in merged list. This is the same. And I think, oh wait, this pattern is not good. Because, yeah, no, we have two values here and here, so we can identify. We can identify the smaller one, and the other value follows other value and follows the other value. So it's between them. The other value is between the other values. In that case, we can identify the index. But it seems complicated, so I feel like there is more smart solution. And also I have to think about this case. We cannot identify. So in that case, we picked this one and this one. And b minus 2, there is b minus 2 numbers in nums 2 at the most, so anyway, let me code it. I want some tests. So what we gonna do is two parallel binary search. Not parallel. We will do two binary search at the same time, and we compare the middle values, and we are trying to identify the index in merged list, and if it's greater what should we do? both index should be halved. I think so, yeah. So we have MR and I'm not sure this condition, but the other one might be the same. No. Yeah, same. We might identify the value in the list, and on the other hand, the other we are going to search in other lists. Yeah, middle of M should be maybe, I think we are gonna this is a hard problem. Let me some simulation. One, two, three, four, five, six, 7, 8, 9, 10. 10. So 4 and 5. 1, 0, 1, 2, 3, 4, 5. 3.5. So how to identify? Four one, 4 1. That is 5. Means 1 2 3 4 5 6. We have 6. We have 6 values. We have 6 values and oh, okay. Why we did have to use them? I forgot. Because it's obvious. The index is 4 and index is 1, so there sum of the total is 5, index 5. That means there are 6 elements we have, and in this case we want to find out the index 4 and 5, so should be going down, going smaller. So what we can do is to going down, and yeah, I think which one should we going down? 3 and 5. Okay, I see. When we are going down, we have to check the values. We compare the values, and 3 and 5, and we have to make the bigger one smaller. So in this case we choose 5. So we choose this list, and we are going to next step in binary search. So it should be which one? This one? Yeah, I think so. So the step 2, the index must point to 2 and 3, right? And the index is 1 and 1, so the value is 3. Value is 4. Value is 2. Press 2. Zero, 1, 2. Okay. 0 1 2 3 0 1. So the overall index is 4. That means we have 6 elements, and this case we have 4 elements here. 4 elements here. And so we wanted to find out the 4th element, so this element might be the answer. But I don't know. We can fix it. One, two, two, three, three, four. So this case, 3 and 4 is the answer. But this might be too big. This case, 1, 2, 3, 3, 4. One of the answer. But it might be this case. One, two, three, 1, 2, 3, 4, 5, 6, 7, 8, 9. 6. 1, 2, 3, 4, 5. 6, 7, 5, 6. So the problem is how to find out the answer, how to fix the answer. 0, 1, 2, 3, 4, 3, and 30. 0, 1, 2, 0, 1. There is 5. There is 5. And this is one of the answer. 1, 2, 3, 4, 5, 6. 5 and 6 is the answer, right? So one of the answer. And how to find the fifth number? 1, 2, 3, 1, 2, 3, 4, 5, 6. So in that case, we have to check the previous value, or the value next to this, because we already have 5 values, and I'm confused. This might be 20. So, but there are 5 values. We identified 5 values. This is the largest value between them. So this must be the answer, one of the answer. And one, two, three, four, five, six. Oh. Oh, I see. When we find the one answer, then we just check the index, that value. What is the index of that value in the other list? So in this case, 30 will be placed here. So 0, 1, so 0, 1, 2, 3, 4. We have four elements before 30, and for this the index is 1, so the 30 would be 6. So the fixed information is 30 is the one of the answer, because we have 3 elements here and we have 2 elements here, and the bigger one is a 30, so 30 must be fifth value. might be fifth value. Fifth or sixth. Fifth or sixth. Yeah, but why it won't be the seventh? I cannot explain the reason why it won't be the seventh. I think it's because we compare this value and I should prove it. So the first step, 0, 1, 2, 3, 4. 1, 2, 3, 4, 5. There are 5 index and 2. We compare second value and fifth value, right? And the fifth value 31 is greater than 30, so we halve it 1, 2, 3, and 2 remains. So we already checked the which one is a 7, so which one is a 7, so the remaining within 6, right? So we compare fifth and second, and the bigger one is removed, so the remaining candidate within 6, right? And the next one is 3 and 2, so we have 5 elements, and the target is so the target is 5th and 6th, and we have 5 elements, so the bigger one must be the answer? I feel like I think this might work. Medium, 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 medium. Let me see this case. The total is 7, so we cannot find out the current 31 and 300 would be the answer or not. So we are gonna halve this, but the 300 is bigger than 31, so this should be should be reduced, and this one is like this. Thirty-one remains, and this one is point to 200 and compare them. We have 5 elements within 6 elements. Okay, wait. So we have to care about this case. So in this case, I see. So we cannot remove element from this one because we cannot we just remove the second list. We just remove the element from the second list. So this one still remains. And is it correct? I think 31. So strictly we have 40. Because we didn't compare 31 and 40, so we don't know which one is bigger, so 40 might be less than the 31, right? So we have 40 still have 40, and this case smaller one is bigger one is 300, so we can remove this one, and 200 we have only 200. And for first list we compare 31, but the remaining part are not compared with 300, so we cannot find out which one is bigger or not. So so in this case, the pointer should point to 31 and 200, and yeah, we have 6 elements. Within 6 elements, no, because we just okay, so this statement is wrong. One, two, three, four, five. 1, 2. Okay, and we compare them, and bigger one. So this case, we compare. We can remove this part. Yeah, that makes sense because it's must be greater than 7th value, because 31 is the 7th value, so yeah, we can remove them, but we cannot this 40. Really? Yeah, we cannot remove this because might be this case. It's this is obvious, so we can remove from 31 to the bigger values, and we have and the point is point to 3 and 1, right? And we have 5 elements within. We cannot specify the range because we have so prove that seventh or greater values in merged list are removed in nums1. We can say 7th or greater values in merged list are removed in nums1. That is this part, but we don't know the nums2 have what numbers we have in nums2, and this case we have 5 elements. Mm. 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 So this case we compare 1 and 3, and the bigger one might be the answer. But okay, so this case 3 would be placed here. The index is 0, 1, 2, 3, 4. So we have 4 elements. Hmm? And I realized this is not log m plus n. This is log m plus log n, I think. So one, 5. 5. 5 5 and we get 4. Means one index. I will use one index. Pick the middle one and find out what index is it in the other list. In this case, 5 and 5. So we have 4 elements before it for each respectively. So we do the same. Two. Three, 4, 5. We pick some value and I give up. Intuitive Python solution. Find the median Solaris L. Case. A and B. K is bigger than the sum of A and B's median indices. Its median, its A's median is bigger than B's. B's first half doesn't include K. What the what? MA is bigger than B. So in this case, the element number of element isn't enough. And MA is bigger than MB. Case number what is it? K. So B's first half doesn't include K. Makes sense. Interesting. I wanted to come up with this solution. So let me see. Case function returns case element, right? Case element, right? Yeah. So the makes sense, and there is 4 patterns. And we are thinking about the 5 and 0, 1, 2, 3, 4. 4 and 2. Yeah, we are thinking about this case. K is smaller than the sum of A and B's indices. Yeah, and A's median is bigger than the B's, and A's second half doesn't include K. That means this is that A's median bigger than B's, A's second half doesn't include K. So we have to call until this one and B and K. this is smart. I wanted to solve this problem without seeing solutions. But anyway, I almost understand the solution, so let me try. So we are gonna implement a helper function that returns case element from the merged list, and this function takes nums1 and nums2, right? And also takes k that indicates the case. Yeah, and if not nums1, right? If so, it means nums1 is empty. It should return nums2 at the k, the number at the nums2 k, case number in the nums2, right? And if not nums2, return nums1 k. Yeah, we do the same for nums2. And we have to find out the middle value for each list. So the index 1 and index 2 is nums1, nums2, right? And we have A and B. It is nums1, the middle value of the nums1 and middle value of nums2, right? Yeah, and we have we have 4 patterns. Let me do this pattern first. So I1 plus I2 is bigger than k, so we have to remove the bigger numbers. So that means we compare A and B. Let me do this pattern because we were simulating this pattern. So A is bigger than B. This case, we can remove the numbers from nums1, right? So it means case self doesn't change, right? And vice versa. We just remove numbers that never be the answer. And otherwise, what if I plus I2 same equal to the k? But it's okay. Let me think about this case. So we can fix some numbers because I1 plus I2 is less than k, so means we can fix some numbers in the merged list, and B is less than A. It means the numbers in nums2 are fixed. Okay, so return case self. So we have to pass nums1, nums2 gonna be right, because B is fixed until B, numbers until B is fixed, so the K should I2 minus 1, right? When the length is even, k minus 1, Hmm. Hmm. 3, so the k is 1. K is 1. K is 1. I1. I2 is 0. I2 is 0. K is 1. So this case might contains k equal to I1 plus I2. One and 0, and 3 is big. So this one, 3 and 2, right? So that means should like this, because right now we reaching here, and 3 and 2. A is 3, B is 2. In this case, 2 is fixed. Yeah, 2 is fixed. But we require more. We search for more answer. But the answer is just 2, right? So something wrong. Yeah, because this implementation doesn't care about I1 plus I2 equal to K. Yeah. I think this is, yeah, the base case is like this, so I think for this pattern returns the kth number. In this case, I1 plus ij is less than k, so it means some of them are contained. Some of them are included until the medium, but we have to we still have to look for the case number. So yeah, so we reduce the k and call for next. In this case, I1 plus I2 might equal to k. Might equal to k. Something wrong. Might equal to k. So it means I'm confused. Oh yeah, I think the number at I1 might be the answer, so we have to and otherwise I1 plus I2 never equal to k, so never equal to k, so yeah, let me see the result. Maximum recursion depth exceeded. Really? I plus. Oh, exactly. Oh, oh, let me do. Okay, okay, okay. Ah, I understand. B is A is bigger than B, so when k equal to, or let me see. When k equal to I1 plus I2 and B is less than A, B might be the answer, but A is not the answer, so we can remove nums I1 itself. So the signature is like this. Right. This case, I see. see. Okay, I understand, and I wanted to solve this. Yeah. Okay, so but I it was interesting, so I'm going to solve hard problems every day, and yeah. But today I will finish 3.